I ask you to please help me welcome Thomas Landolt.
I'm obviously very honored to talk today in front of such an expert audience. I'm neither an open data specialist nor an expert in matters of public administration. I'm just a simple business guy. And instead of presenting you therefore yet another aspect of open data, I'm showing you what we at IBM believe is happening in the fascinating world of data. And I show that publicly available data will certainly has to play a key role in it. Let me start with the very first slide of our own strategy presentation to our investors. We see here three major shifts which impact all industries. They all happen in parallel and they all influence each other. The first shift deals with the transformational power of data, and you wouldn't sit here if you wouldn't know that already. The second shift deals with the way how this is being delivered, ever more flexible and dynamic, which leads to an unprecedented need for scalability of many of those new emerging business models. Shift number 3 then addresses the way how we engage with individuals, giving them a consistent experience across every interaction they do. It's obvious that shift number 2 and number 3 are also driven and supported ultimately by data. So, cognitive computing then is our new paradigm. We see this as a new era. It's not a single product. IBM Watson, you may have heard about this already, is the poster child for this. But cognitive is overall a much bigger concept. It's around learned versus programmed solution, conferring a thinking-like ability. This is also about augmenting human intelligence as opposed to replacing it. One question you may have is, what the hell makes a cognitive system different than the types of systems that exist today? Or what makes a cognitive system than just simply advanced analytics? Up to now, systems have been programmed. This means their outcome is designed by the person that programmed it. These systems, by design, are predetermined based on a rigid set of parameters defined for specific outcomes. These systems are, of course, what we consider deterministic. A cognitive system is different, as it is not programmed, it's trained. This means they learn and reason from their interactions with us and from their experiences with their environment. They do not give predetermined responses, but are probabilistic. This means they generate hypotheses, reasoned arguments and recommendations. Because of this, cognitive systems can make sense of much of the unstructured data that exists in the world, and they can scale to keep pace with the complexity and unpredictability of information in the modern world. In this new era, we need to look at a system that has the ability to consume data from a breadth of data types. This means relying on programmable systems for back office efforts, but cognitive systems to engage humans differently, critically advance our combined insight through social and physical interaction. Let me show you an example from the mergers and acquisitions world. So they would now speak, obviously, if that would work somehow. So just use your imagination. They talk now through some politics. Is it not working?
I found 3 companies similar to the ones you specified.
Beautiful. Well, let's see what we think of these. Dive a little deeper. Let's compare these things. Sure. Watson, show me a decision table.
Here is a decision table that will enable you to compare companies side by side.
Watson, place the companies named Wolfram Alpha and Kawasaki Robotics and Cognalytics and Raytheon BBN Technologies and Decisive Analytics in the decision table.
Okay.
Okay, but I think we need a little more than that. We need some other attributes. Watson, place the attributes named revenue and employees and corporate structure in the decision table.
Okay.
All right, so now we've got this side-by-side comparison. What do you think?
Yeah, I think that's right.
Watson, give me a suggestion.
I have a suggestion.
So, the technology for this exists, and while this is obviously has been built by marketeers, the system, similar type of system, we're already building also in a project here in Switzerland. Watson is actually already being used in many different industries. An early application has been in the area of healthcare. A simplified example here shows its key characteristics, such as understanding natural language, being able to go through large volumes of unstructured data and generating hypotheses from there. Those are then evaluated and the resulting confidence level is then presented. The system is built on a dialogue which allows to refine the results. The system presents possible answers to the physician, but he then takes a decision. The physician takes a decision. This is fed back to Watson, who learns from those decisions over time. You can already see here, those systems derive on data, large amounts from a variety of sources, structured and unstructured, and also growing over time. Watson's first public appearance took place in 2011 to win the American quiz game Jeopardy! Back then, 5 capabilities were being used: natural language understanding, machine learning, question analysis, feature engineering, and ontology analysis. Since then, we've broken this one system up into a number of openly accessible services, and we've added a large number of additional capabilities to the mix. This large number of different services, different cognitive services, is the reason why we claim to be at this point the leader in cognitive technology. A single API can provide significant value to an application, but often multiple APIs are combined in an app for more powerful results. For example, speech to text and text to speech with dialogue and natural language classifier can be combined for an engagement pattern. Add in language translation to the same app to expand your user audience, for example. We are expanding our tooling to help developers create applications with the APIs more rapidly. Customization features are available with some of the APIs. While some APIs are ready to apply without additional training, others allow you to train Watson on your own. I mentioned already that Watson consumes various sources of data, and a typical application uses data from the public domain, but also very specific and also personal data. Domain-specific information, such as ontologies or specific patterns, are being introduced too. From there, the system is trained with the subject matter experts. The result belongs to the entity, the firm, which built this system. If, for example, a system for insurance underwriting is trained, this will be done with the insurance experts of that company. Any other insurance firm has to train the system from scratch, but we're using the basic structures and ontologies which are in the public domain, but without the specific knowledge from the other firm. So far, we are very strict with this, since we can't hand over knowledge which may provide a competitive advantage from one firm to the other. One can imagine, though, that over time a fine line can be drawn between what type of subject matter expertise is in the open domain and what is specific to a company. Let me come to another example, how we work with data, both public and proprietary. IBM acquired about a year ago the weather company. They deliver the information for a number of widely used weather applications. You see some examples here on the slide. Weather information is used, of course, in many industries, for example, in insurance, farming, retailing, but also in public services. We believe that the better use of this data, applying predictive capabilities and combining it with company-relevant information, will be a source of value for many firms. Operating such a network of data on a global basis, delivering data in real time, is also a critical capability in today's world. To give you an idea about the scale and complexity, many different data sources, both proprietary and public, as I mentioned, provide the data, which is then processed and distributed at a massive scale and near real time. Globally, about 26 billion requests are handled every day. Besides the open data, the company's own data stations, also private weather stations, deliver their data into the network. This data and the analytics are made available, again as services on the same platform. We call it Bluemix as the cognitive services which I mentioned earlier. This allows for a straightforward implementation of advanced services on the basis of weather data. For most of today's cognitive solutions, the model is as follows. Data is being collected from numerous sources, sensors, or other data points. That can be structured or unstructured or something in between. That data comes in large quantities, possibly at a high speed. The confidence in the sum of the data varies. In a subsequent step, this data is then processed and turned into information. This will include various types of analytics, data cleansing, and various models to create and derive only what seems to be relevant. Lastly, this information is then fed into a cognitive system to create new insights, which then turns the information into something which could be called knowledge. Well, the step before can be done without much industry and domain expertise. It becomes clear that this expertise plays a critical now in this last step. An interesting aspect, which is still a topic of research, is there then common sense knowledge. This is the collection of facts and information that an ordinary person is expected to know. The goal would be to create a common sense knowledge base, a database containing all the general knowledge that most people possess, represented in a way that is available to artificial intelligence programs that use natural language or make inferences about the ordinary world. Such a database is a type of ontology. The semantic web and semantic analysis related to natural language processing are a relevant part of it. Standards and technologies such as RDF, OWL, ontologies and taxonomies are very relevant in the cognitive computing discussion. One may think of cognitive computing as structured data and decision automation as structured data like standard business applications. But a lot, or most of the new applications of cognitive computing are completely unstructured sources, and sense needs to be extracted from the content and mapped into semantic vocabularies of one sort or another and managed into repositories. For cognitive computing to achieve its promise, we need a thick metadata layer that incorporates semantic tagging formats. The linked open data models can deliver very valuable ontologies that can indeed be used for cognitive computing today. Some of those models can be done by groups or individuals or crowdsourced. This is, in my point of view, a very relevant aspect for the open data community for the near future. At IBM, we are supporting open data in various different aspects. It is, I have to be honest, still a topic which is very much under development, And while the topic itself is developing, also our approach to it does so. We don't have all the answers. IBM is making those significant investments in a wide range, for example, of cloud data services that build on open source database and analytics services. We also provide a service which allows access into most of the open source databases. And we provide open frameworks, such as, for example, tool and platform for graph analytics based on the Gremlin graph-specific query language. And we provide self-service, again, IBM Bluemix-based platform, data marketplace for easy access to high-quality data sets that are ready to use, again, for incorporation into machine learning, advanced analytics, and other applications. We also announced new and advanced IBM Watson application programming interfaces on the cloud to accelerate the emotional and image recognition capabilities of cognitive systems, in addition to the services which I've shown you already on an earlier slide. These cognitive APIs enable developers to tap into Watson's emotional and visual senses, further extending the capabilities of those technologies. IBM and GitHub also announced a strategic partnership to offer the GitHub Enterprise service in dedicated and local hybrid clouds. IBM is also giving regularly code into open source, such as, for example, the Quarks framework, which is an innovative cognitive IoT, Internet of Things, development tool, but also code, for example, for Hyperledger, an open blockchain initiative. We are also a member in a number of groups and projects, such as the Data Coalition in the US, City Forward, a number of local initiatives like COPE in Minneapolis, Dublink, Dornat, Intelligent Transportation. Quite frankly though, I don't know where this is primarily due to local initiative and where this follows a bigger strategy in our company. Probably a bit of both. I wonder if we and where we will also contribute finally to the development of semantic webs and other areas such as the mentioned commonly used taxonomies, ontologies and linked open data to further support the development of the cognitive aspects, what I mentioned on the common sense. For several decades now, the information technology industry has relied on technologies and compute infrastructures that were designed and optimized for transaction processing. Advancing by the trends captured in Moore's law that increase computational speed, density of compute elements, and also the speed of interconnects. Two major shifts point now to an opportunity to disrupt this trajectory over the next decade. The first is a shift in workloads from the transaction-oriented ones to those that extract insights and understanding from vast quantities of data. While traditional transaction processing workloads will probably continue to grow only modestly over the next decade, the computing requirements of cognitive workloads are growing exponentially. At the same time, many of the technologies and architectures on which computers are built today are providing diminishing returns both in performance and in economics, and are becoming expensively to scale even linearly right now, let alone keep pace with the exponential scaling that the workloads of the cognitive era demands. The state of the art to address these cognitive era requirements, exemplified by machine learning, graph analytics, video analytics, and other such workloads, is to run them on the traditional systems and offload certain portions of the workload to specialized execution units. For those deeper understanding, know them under FPGAs and graphical processing units, GPUs, and so forth. But they are still built based on traditional architectures and devices. However, there is an opportunity to build an entire family of systems and data centers that are redesigned from the ground up for these cognitive era workloads, with the aim of providing orders of magnitude improved performance for them. Foundational to this roadmap is the revisiting of many of the assumptions on which traditional systems design is based, and tailoring the new system to be directly consistent with the attributes of these cognitive era workloads. Instead of systems optimized for highly reliable operation and accurate and structured data to produce deterministic results, the path forward envisions systems that are resilient, capable of operating in noisy and unstructured data, and produce results in terms of probabilities. Examples of computational fabrics that represent this evolution include neuromorphic and quantum computing systems. An example of an emerging compute fabric is the Synapse neuromorphic chip. Picture, not too visible, you have on the left-hand side. This brain-inspired chip enables sensory perception in mobile and Internet of Things applications by implementing a low-power, scalable architecture. The most recent version of this is the IBM True North chip, which contains about 1 million neurons and 256 synapses implemented using 5.4 billion transistors and consuming only 73 milliwatt, which is about 10,000 times less than a conventional architecture would require. As part of a cognitive hardware and software ecosystem, this technology creates new possibilities of transformative applications and devices with sensory perception. These include applications in robotics, healthcare, public safety, environmental protection, and many others. On the right-hand side is another example of an emerging compute fabric, the quantum computer. Quantum computers promise exponential leaps in speed and power by exploiting quantum superpositioning to represent multiple states simultaneously. Honest, no question about quantum computing afterwards. Some of the advantages are obvious. Speed to handle process-intensive workloads and the power to scale out depending on the business need. But the real differentiator here is that these benefits compound quantum computing's true strengths, which is an entirely new way to tackle problems. Harnessing such capabilities would provide extraordinary business advantages by accelerating innovation and solving problems that are unsolvable today in areas as diverse as pharmaceuticals, encryption, and material discovery. I tried to show you that the fascinating world of data is still emerging. The availability of data, but also what can be done with it, is growing at massive speed. New technologies, new models, new discoveries, and also new applications pave the way for massive opportunities. The rules, the do's and don'ts, still have to be shaped. While we don't want to hinder the developments and the opportunities we have also to be mindful of the responsibilities which come with it. I've showed you what we are doing at IBM. Of course, we want to earn money from it, but still with the aspiration to ultimately provide also solutions for a better planet. Thank you for your attention.
Many thanks indeed for this presentation. So about quantum computing, let's not do that. So we got plenty of questions from Twitter, and many go into the direction of what open data do you contribute? Because I understand very well also the examples of how when Watson needs to win Jeopardy, it needs to ingest tons and tons and tons of data in order to build that body of knowledge. But then again, that's public data that has been put on the internet by people and by governments and so on. But you're at a scale where you also have so much data, and where, of course, the first question that's going to come for the community, what data are you sharing back?
We are primarily, and have to say that, the consumer of data, and the consumer, and we give that, we provide that in the form of services, again, to our users. We are not interested in keeping that data just for ourselves, because that's not our business model. We are specifically not interested in keeping personal data, which is also which needs to be very clear. That's not our business model. We try to work in partnerships, or obviously in partnerships where we're also earning money with companies, where we would deliver primarily the analysis. So probably with the example of the weather data where we talk about the combination, ultimately what we want to do is provide the analysis which goes to the cognition, to the discovery of patterns, but it's not the idea and not our strategy to build our own data-driven business models out of this. Now, I know that's a fine line, but with this also we will not become a second. We are probably also need to say we are a business-to-business company. We will not go into the consumer market, and hence also again not being interested in those type of business models where we would ultimately provide data to the end consumer.
So when Marcel Salate at the beginning said that who owns the data and who has control over data is going to be more and more important in that age of intelligent machines, you're saying, yes, that's true, but from your point of view, you're building the tools, you're building the machinery, and actually you don't want to be that kind of data owner and be part of those power plays. You work with anybody who has data to extract the best of it.
Exactly. Now, obviously, there are borderline cases there. You can say, again, the example of weather data. But it's ultimately our clients who would then own the data.
Sure. Okay. And then you had one example where you talked about a data marketplace for data scientists and for developers and so on. So that's interesting, because when we're talking about open data platforms, we're talking about platforms where stuff is made available, and we're not talking about marketplaces. So how does that work together? What is the supply and demand function there, and how does that market work that you have there?
I mean, obviously we will not be able there to charge for data or for, it's primarily, I think that you need to let me go back one step. I think there is a distinction between the services, between the API and what value do we contribute as part of providing an API and a service. And depending on that, we would charge money. Different commercial models exist there. What we can't do, obviously, we cannot just provide data which we get from the public domain and then through a marketplace sell this forward. There needs to be a value add, otherwise, why would you access such a marketplace? So for us, I think more important and what we want to provide is that platform with those services. And some of the services, even today, some of the services come for free. Other services, we charge money for them. And then obviously everything in between.
Okay, so another thing I was wondering when listening to your talk is that, you're a huge corporation, publicly traded and so on, and usually in that context, people tend to think from quarter to quarter, right? Because the financials, that's how you measure it and that's how it goes. And when you talk about open data, in many cases it's about the long term. You want to build an ecosystem, you want to build a sustainable community like we're trying to do here. And there seems to be a conflict that you are somehow managing rather well, because we always see those long-term things like, Watson and the quantum computing and all of that. Those are long time investing. How do you guys do that?
First of all, given that in the final 2 weeks of the quarter, I just come here, should show you that you can draw somehow, kind of make the balance. No, I think we still fund for example, our research team quite generously, and we also see this as a major part of our future success. That is certainly one aspect. And obviously our bet we are making into cognitive computing, our belief that there is really something new emerging here is certainly at the core of our strategy. Hence also the need to make investments there. But then finally there is a lot of also short-term decisions, and especially in preparation also of this speech, I tried to figure out what is now really our plan and our long-term strategy in terms of open data. And I need to tell you, a lot is also done there on the short term as part of a certain project, of an idea, working together with the city government and see what can be done. So it's a bit of both.
So maybe as a last question, let us pull things back together when it comes to the relation between communities, governments, and what technology does and what data does, right? And so one of the topics that you're very active in is the idea of a smart city, right? And in that context, we always have the idea that, okay, for a smart city, you do need those kind of Internet of Things, and on the other hand, you need some sort of open data in order to make sure that citizens actually can have a part, can have a say, can have a role in the analysis of what's going on in the smart city. So I know that's a huge topic for you guys. I think you even came up with the term somehow, right? So smart city and open data. What's your agenda there?
I mean, this is exactly one area where we absolutely see and support the need for open data, because without this, I mean, it's nobody can really develop reasonable applications and reasonable approaches to deal with the many different topics. And if I say nobody, then the same would be true for us, and hence. Yes, if I mean, especially in public institutions, which are essentially funded through taxpayers' money, I think this is a very essential and very critical discussion, which helps us, but helps everyone else who wants to participate and provide services in that ecosystem. So that's why. But if you ask me, do we support open data in that space? Yes. Who would I be if I would say no? So,
sure. Okay. I think it comes back to common sense, which you had in your very title, that for open data becoming a topic that is not something that we hacker types like talk about, and oh yes, we want to have all that data to build funny things at our hack days, but it really becomes a common sense concept for governments, but also for corporations like IBM. And for me, that's a great development to see that somebody like you comes here not with the title Open Data, the future, question mark, but open data, it's common sense.
I mean, as part of a reliable and highly developed data infrastructure, open data is certainly a key element in it, as there are many other topics and questions. And what I also tried to show, I think it's still a bit Wild West around data. We start to see the possibilities and what emerges here, and quite frankly, I myself, I still marvel at what this is coming up here, and I deliberately also include the last slide talking a bit about technology to show you this is only the beginning. Now, in order to really grow and in order to really be able to develop on those things, then there needs to be certain things which are reliable and certain things we can build upon. And hence, yes, but I don't think that there will be many people out there who would question the value and the need for open data. Ultimately, the question is always who pays for what, and that's obviously where then discussions really start.
Of course, and I think that is a question that we can continue to discuss at the apéro. So in that sense, I would say many thanks indeed, Thomas, for your share of common sense. Thank you very much.
You're welcome.